Hello everyone. This week we will be talking about the statistical analysis and interpretation of survey data. And before we do that, in data pre-processing, what we are looking here is the validation and editing. Validation is basically to making sure that the data we have were specific to our project, that they are specific data, and generally editing, the idea behind the editing is that making sure that um, people follow those skip patterns properly, for example, and people have completed the survey as they're supposed to complete, and all the logic and the questions were followed, just to look for some any missing values, making sure that just it's just basically before we're doing any data analysis, just kind of making sure data is correctly in correct format and correctly organized, really. And then the next thing is coding. Coding is basically if you have those open-ended questions. Um, Generally speaking, of course, it could also be some other numerical question, but coding is basically when you organize responses into categories. So as you probably remember in your previous course, sometimes you have to code your data, especially if you want to create some sort of a categories. So let me give you an example of a coding here. So what we have is, let's say you have this question, what is your age group? And these are the responses. Okay, and so these are the answer. People might choose one of those answers, for example. And so what we do in SPSS is, well, one good thing about SPS online surveys are a lot of those data are easily transferable from Excel to SPSS, or sometime depending upon the what tool we use. Sometimes it's also available is also in a SPSS format. But again, I would still recommend that you make sure that you have a look at your data before you start analyzing your data, just to making sure that this is the exactly format you expected. So what you're really seeing here is basically the code. So for anybody under 25, you give them a code 1, 25 to 44, you give them a code 2, etc. So that's what we see here coding is. Okay. And yeah, so that's question labels, those are values, the code values. And after coding, the good news is, because as I said, if you're doing online survey, you don't need to worry about data entry. Data entry is more specific when you're dealing with the paper questionnaires. Data transformation it has many meaning. One of the purpose of data transformation is to make sure that data is in a proper format. So sometime you might hear me telling you that make sure that your data is in numerical values. So ensuring that when you do a data analysis, that the values are numeric values. Of course, you can always code those numerical values, coding as I mentioned 1, 2, 3, 4, whatever that may be. So that's what kind of transformation we're talking about. And some of the other transformation also, it might also include some recoding. It might also include some sort of transformation to log values, or some other calculation which might be required to prepare those data. So that's what really transformation is. Once you have a data set, once you feel okay, we got data set. So the first thing is to run some descriptive statistics. So basically, descriptive statistics is basically you are summarizing your data in an informative way, so this way you can understand what data look like. And I think this is good practice. So one of the common way we're doing descriptive statistics is looking at some of the frequency distributions. So frequency distribution is basically you're looking at the how many observations we have for those specific variables, how the data look like. So we kind of look at the distribution. So and of course we can draw some graphs and charts. That always helpful, because as you can, from graphs or charts, you can you can you can see the distribution in percentage format, or you can also see if there's any distribution, how the distribution look like, some skewness in the data, or any anomalies, any outliers. Those are easily detectable if you see some extreme numbers showing up in your distribution. Okay. Then next thing you really want to do is to look up some of the summary measures. We'll go over the summary measures. Summary measures typically, like mean, median, mode, things like that. Okay, so let's quickly go over some of the graphs and charts. So what graph you see right now here is this is of course this is a histogram. So histograms, the bars attached to each other, because generally when you say histogram, we'll be talking about numerical variables. And by looking at histograms in this particular case, you can see that it has a zero skewness. Normally zero skewness means that when mean of the data is same as the median and mode. So that's what we see in this example. And yeah, so we definitely see that it doesn't have a skewness, so skewness is not here. How do you calculate skewness? There's a formula for skewness. Is basically the mean minus median times 3 divided by the standard deviation. And that's what give you kind of skewness. So it's kind of obviously you can say that if mean is more than median, then it's as a positive skewed. If the median is more than the mean, then of course this is a negatively skewed, for example. So this is the general way. So I'll show you this what does a positively skewed distribution look like. So this is what this positively skewed distribution look like, because the mean is the largest of those three measures. You can see that mean is more than median and mode. Okay, and basically in the positive skewed distribution, you can see that the tail of the distribution, the asymmetric tail, extending towards the more positive value. So basically there is a values which have very high value, generally speaking. So those are the positively skewed skewness. And the next one I'm going to show you is the negatively skewed distribution. So we can see that in this particular case, the mean is the lowest of the three measures. So in this example, either mode or median, which is higher than mean value. And again, the negative skewness indicate the distribution with an asymmetric tail extending towards more negative values. So generally speaking, as you can see that because mean is less than the median or mode, so there is some values which is going towards the left hand side. So that's what the left skewness really means. And again, because this is a numerical value, so of course, as you can imagine, I mean, it could go any infinite numbers of values which can be on the left tail of the distribution. For example, like if it's even, it could be negative numbers, for example. I'm going to show you this some real data set. I have posted this data set for you to look this data set on your Blackboard, so you can practice analyzing some of the numbers you're looking right now. So what I'm really showing you is a histogram, and this histogram is showing the income of families in car ownership, ownership, and yeah. So this is basic histogram, and again, this is what the real data look like, and of course you can see that the data look like it is a positively skewed, and that's what it look like. And of course, you probably heard another term quite commonly people say frequency polygon. So frequency polygon is when you of the histograms, when you connect the midpoint of the bars with a straight line. So let me show you here. This is what I mean by that. So this is the midpoint, right? So this is a midpoint, this is a midpoint, this is a midpoint of the bar, this is a midpoint, this is a midpoint of the bar. Okay, so you probably remember this thing. So this is so yeah, so kind of interesting, because this way you kind of see that what the distribution look like. So this is basically known as frequency polygon. When you connect the midpoints of the bars with a straight line. Yes, it's of course not perfect straight line, but I try my best. But that's what this histogram look like. Okay. One thing you notice that every time when I'm showing any chart, I always try to have a label. So this is very important. It's a good practice to have a labels, relevant labels for the chart. And yeah, so you have the x-axis has a label. In this case, is the income in dollars, and the y-axis has a counts. Frequency is basically count number of people in these income categories. And I would not really write down histogram. I would probably write down the distribution of family income actually. But the point here is that make sure that you also have a title for your chart. And then you notice that in every chart when I'm doing it, I'm also providing a little description where which question I'm referring to in the survey, right, and what sample size I'm using. So this is a good practice to make sure that you provide as much info possible. The next thing you see is a bar chart, and because we are dealing with the survey data, and typically in survey data we have this Likert type of scales, okay, and normally those scales will have, this one example is showing a 4-point scale. Of course not my favorite one, but this is the example of 4.1, and normally it's quite common because you can see that, right? So satisfied and somewhat satisfied. This could be treated as a like top 2 box, okay, and this could bottom 2 box. So it's quite common in research presentation, especially in when the research is more intended for business purposes. Then you generally present top 2 score on the bottom 2 scores. Especially if you have a lot of attributes. In this case, this one is a customer satisfaction. So this way, we get a better understanding. You know what percentage people are satisfied, somewhat satisfied, because this kind of give you idea that this is kind of more like satisfaction range, satisfaction of information, and this is more like a customer dissatisfied. This kind of combining of scales is quite common in research. The next one you see is a pie chart, and of course, pie chart. Of course, when this pie chart is used for a categorical data, and this creditors and non-creditors, and generally I would not use pie chart if you have a lot of categories because kind of lose this appeal. So not necessarily try not to have too many categories in that particular variable for the pie chart. So that's the pie chart is. Again, the choice of the chart depend upon what you try to communicate. The next one is basically, I mean, this one is really known as a line chart. It's known as a line chart. This line chart or the line graph are useful when you try to show the relationship between one variable and another variable. So in this case, we're looking for the household with at least one public transit users by the time. So it's basically showing kind of trend. It's kind of also showing what's a trend look like. So this is what the line chart does for us. I mean, technically it is a scatter plot, or we connected the scattered points with this line. So very useful chart. The another chart is called cumulative frequency distribution. Is basically it's a cumulative frequencies are shown in the chart. And I want to go over now some of the summary measures, and summary measures are divided into one is called the measures of central tendency and the measures of variability. Sometimes we also call the measure of dispersion and the measure of position. So let me show you quickly those summary measures. So the one I'm referring, the measure of location, is also known as measure of central tendencies. So as it says, the purpose of this measure of location is to determine the central data values or most typical data values. So those measures are the mean. So mean is relevant for a quantitative data like ratio interval level data, for example. Then we have a median. Of course, medians generally are less sensitive to the outliers compared to the mean values. The outliers can have a strong impact on the mean values. And then we have this the mode. The mode obviously is the most typical value or most frequent values in the data set in that particular for that particular variable. And the measure of variability sometimes is also known as measures of dispersion. So it's basically, it shows you that what degree data values are scattered away from the central value. Central value is, again, that is your mean values or the median values, even mode, right? So typical of the variabilities measures are your range. Range is the difference between the high value and low value. And then we have the variance. The variance is the square deviation from the mean values, right? So basically you take the mean of that variable and take the individual values, subtract that mean, and divide it by the degrees of freedom. That will give you the variance. Okay, and square of the variance is a standard deviation. So again, these are good measures to see how your data spreads, what's the variability in your data is. So there are three measures of position. The one is quartiles. I'll talk about them in a minute. Let me show you deciles and the percentiles. So what quartiles are? The quartiles are the percentiles which divide the data into three quartiles actually. So it's a Q1, Q2, Q3, or four equal parts of your data sets, okay, or the four equal groups. So for example, your first quartile will be a 25th percentile, right? So again, what is percentile is? So percentile is basically, for example, let's say if you say 25th percentile, so basically your first quartile separate the bottom 25th% of the data from the top 75th% of the data, right? And what about the second quartile, which is your 50th percentile, and 50th percentile is a median, right? That means 50% of the data is on the top on the top percentage, and 50% are on the bottom. For example, that's a median, right? And if you say third quartile, so third quartile is just 75th percentile. So again, the third quartile separates the top 25% of the data from the bottom 75% of the data, right? So that's the percentile, quartiles, and deciles. Deciles basically divide the data into nine deciles, or 10 equal regions. So those are the deciles. So these are your measures of position. Let's talk about some of the tabulation and statistical analysis, and of course, as I'm talking about this stuff, I'm talking about in reference to your survey data, so that you can look at your data and analyze your data. So before we do data analysis, so of course, the mere meaning of tabulation is a frequency table, or the frequency count of each question in your survey, right? So that will give you the information of one variable, for example, right? What's the distribution look like for one variable? So you can tabulate them, right? Tabulate them. Now, quite common in research, we also looking at the cross tab, and this is very common practice especially in marketing research. So what we do in cross tab, so we simultaneously tabulate the responses of the two categorical questions. Okay, that's what we do in a cross tab. And you might have heard this word, we quite common use when you do a chi-square test, which we call the contingency table. That's what this cross tab we're talking about, right? Cross tab in contingent of another variable. What's the word effect of one variable on contingent of another variable? So that's what also interchangeably we use cross tab with a contingency table. So once again, your cross tabs are based upon a categorical variables, and of course you can always convert your numerical value also in categories. Like for example, let's say again, this is example. Let's say you have a variable which has an income, income in actual dollar values, for example, right? Let somebody say the income is 50,000, somebody said the income is 70,000, somebody said the income is 40,000, whatever, right? So what you can do is you can divide this income into categories. Okay, so that is your can become a categorical variables. So quite often, and which I will ask you to do is this is a common practice before we go on and start doing our tabulation, especially cross tabulation. We need to have some sort of plan. That plan is known as a tab plan, all right? So that's what you call them, a tab plan. Let me show you here. This is called tab plan, all right? And when you do a tab plan, so we need to have banner points. So typically these banner points are your columns, and they might be your demographic, such as what is demographic? Education, education of the person, location where they live, for example. It could be their gender as well of the participants. It could be anything. We try to profile them really. So socio-economic variables, geographic location question, which I just mentioned. So those are your banner points, and then you take this banner points. Okay, these are your column. When you create a cross tab using SPSS, you will remember, and I'm going to show you, by the way, after I finish my lecture. You remember that there's a option where you can drag your variable in the column. So that's what the banner points are, and then you run this banner point. So basically you're running this variable against your some specific question in a survey, so which you use them on rows. And another word we use quite often is we call them stubs. I don't know why you call them stubs, but that's how I will introduce calling those specific questions of the row as a stubs. So STUBS stubs. That's called stubs. So if you hear that sometimes people calling stubs, they really mean by the question you're using for a row. Okay. Yeah, so generally this cross tab work very well in a categorical variables. Okay, so let me show you one example, and I posted this data set on your course web page. It's about the family size and the car ownership. You can see in this example we have these two variables, right? So we have this variable family size, right? Okay, and family size has two categories: as family size of 4 or less, and family size of 4 or 5 or more. And then we have another variable which is a number of cars. How many cars people have, families have, 1 car or no car, or 2 or more car, right? So we got this two variables, and each variable have two categories. So basically what we have is, because we have 2 rows and 2 columns, we call them a 2 by 2 contingency table. So this basically is your 2 by 2 contingency table. Of course you can have more rows, more columns, so accordingly you can change your become, let's say, 3 by 4 or whatever that number may be. Okay, and so yeah, so normally one of the things we do is just we try to understand. Of course we always show them into percentage, because percentage make more sense. So one thing we are always want to see is this: is you can see that you can see that the large family, this family, they have 77% own 2 or more cars. That's very interesting, right? Compared to this 10% here, right? Similarly, smaller families have 1 or no car, compared to 23%. So this is an interesting pattern. You notice that, right? So one thing we want to do here is, does multiple car ownership depends on family size? So that's something you want to do. So to do this test, we can do hypothesis testing, and we can use the chi-square test. So so obviously when we're looking at the relationship between those two non-numeric variables, generally your nominal variable, nominal data, or the ordinal data. So we use this chi-square test for the contingency table. So chi-square test is one of the most widely used tests to use, and definitely in business research, such as like marketing research, for example, because I mean, even in other research areas, because we're always interested in analyzing the categories, right? So let me quickly give you a little background. Chi-square, you all should know chi-square because you've been taught this chi-square test in your stats course. So So chi-square test is looking for the association between the two quantitative variables, and those variables are either nominal or the ordinal. Okay. Of course, somebody say, why can't we use for the number variables, the numerical variables, because it has so many categories, it has so many individual values, so you lose degrees of freedom. So that could be a problem. So that's why it's not very suitable for those numerical values. And what we do in this test is we test the hypothesis that the rows and columns variables are independent. So in other words, we're saying that if you go back to the number of cars from the servicing, car ownership is independent of the family size, and of course without indicating the strength or direction of the relationship. Whereas our research hypothesis, we're saying no, the car ownership depends upon the family size. Okay, so I'm going to show the output from SPSS. Okay, yeah, I talked about this. So I'm going to show the output from SPSS, and this is, I already mentioned this number. You can see that this output comes from SPSS, and you will be doing it for your own project. So you can see that, right? You can see that is the larger family tend to have multiple cars. Smaller families generally have fewer cars or no car. So, if you remember, because chi-square is about the frequency, computing a frequency differences. So these numbers, we call them a observed frequency. So these are the observed frequency, right? But this is called expected frequency. Expected frequency when the null hypothesis is true. So let me show you. There's one right up here. So as you can see that expected frequency is the frequency that should occur in the absence of the relationship between the two variables, right? So because if 75%, right, if the 75% is the total percent of people have 0 or 1 car, so therefore 75% of the total sample have one or no car. That means, so to do that, so our expected frequency for this would be basically is a 75% of 78, and that will be your 58.5. As you can see, this one at 75%, 78, 50.9. So this is our expected frequency. I did the same for the rest of them as well. And again, I'm sure you probably remember again how do you get 16.5. If you take 75% of 22, you will get 16.5. 25% of 78, you'll get 19.5, and 25% of 22, you get 5.5. So this is how it's calculated. The next thing is to compute the chi-square test. So let me show you quickly what the hypothesis look like. So of course our null hypothesis is that there's no relationship. That means the two proportions are same. So we're saying that the row variable is independent of the column variable. So generally, if you remember something like this, we say, these two proportions are same. Basically, saying that it's mean that if you're saying that if this is pi 1, then we're saying that this will be same. So this will be same. All right, so this is it's saying no association between the 4 or less or 5 plus family size of this car ownership. Okay, a number of cars. Okay, and whereas the alternate hypothesis saying that there is a related, in other word, these two proportions are not same. Okay, so that's kind of a hypothesis setup background is, and you probably remember from your previous, let me write down 2 properly, it's not properly written. Okay, so people remember from your previous stats course. Okay, so let me show you the formula for the chi-square test statistics. This is the formula, if you remember. So your FO is your observed frequency, and this FE is your expected frequencies. Expected frequency is when the null hypothesis is true, eh? So I think it is right up also here as well. Of course, this is a degrees of freedom, R minus 1 times C minus 1, and because the reason we use degrees of freedom to find the critical value, so we can compare our test statistics with the critical value. So So you already know this one. FO is observed frequencies and F is expected frequencies when the null hypothesis is true. Next step is we go ahead and calculate our test statistics. So test statistics is 41.103. Okay, and then what we do next step, we compare this number. This is our test statistics. We compare this number with our critical value. So critical value, you can get it from the table. I mean, calculators can calculate those numbers. Excel spreadsheet calculate those numbers. So we can, so in this example, the degrees of freedom would be 1 because it has a 2 rows, 0, 1 car, and 2 or more cars, and the 2 columns, small family, large family. The 1 degrees of freedom, 5% alpha is very commonly used, and if you check out your table, the stats table from any stats book, you will see the critical value is 3.8415 from a chi-square table, and we already calculated calculate the test statistics 41.103, and you can see that 41.103 is more than 3.8415. So therefore, we can conclude that there is a relationship between the family size and the car ownership. That's the conclusion we have, right? And of course, we do see a interesting pattern. So what I'm going to do is I'm just going to stop here, and I'm going to show you how to do this using SPSS. Hello everyone. In this part of my lecture, I'm going to show you how to do a chi-square test using SPSS, and then I'm going to show you how to draw a cluster bar chart of your chi-square results. So what we have in this tutorial, based upon my lecture notes, we have this family size. So that comes from the variable number of family members. Here is the variable, and I recoded them actually. So I took this scale variable and I recoded them to family recode, as you can see in my variable view. So this is what you see: one value, one code for 4 or less family size, and 2 for 5 or more family size, and that I use this variable, this scale variable, to recode into 2 categories. Similarly, here the number of cars family owns. This is again, it's a scale variable, and I recoded them into this categorical variable, number of cars. As you can see, this one also here, 1 code represents 0, 1 car, 2 code represent 2 or more cars, and this is what I recorded them based upon these 2 variables here. So what we want to do here is just to run a chi-square test to see that if the number of car ownership depends upon the family size, and that's what we want to do here in this example. So we go here on analyze. Okay, just go and analyze. You don't have to highlight anything, just go analyze and check onto the cross tabs, and then select your variables. So you have this family size, and family size goes on column, as I was discussing the structure about the cross tab in the tab plan. So the demographic information like family size will go on column, which is also known as banner points. And then we have a number of cards which is go on a row. Rows also represent as a stubs, also called stubs. So this is rows. Okay, and we check on the statistics, and we check onto the chi-square. Okay, and then we go on the cells and we click onto the column. We are not interested in other portion of the cross tab. We're only interested in observed frequencies and the percentage of the column percentages, which will be the family size. And that's pretty much we have to do. Don't worry about other options. That options are not useful to us at this point. So just focus on the statistics portion, which is a chi-square, and the cell, which is your observed, and the column percentages. All right, just simply say okay. And what we have right now is a result of the chi-square table. So we got this this very nice cross tab here. So we can see it almost 90% of the smaller family, 4 or less, own have 0 or 1 car, whereas the larger family, which is 5 plus, have 2 or more cars, 77.3%. And this number here, you see that this number, this is your chi-square test statistics 41.103. And of course we can always go back to our stats critical value of chi-square, compare it, but thankfully when we run this test in SPSS, it gives us p-value for us. So when you see this number, this is really is a p-value. So p-value, you can see that is 0.000, which is way less than alpha 5%. Typically we use 5% as a significance level. So this p-value is way less than 5% significance level. So basically it's saying that yes, there is a relationship between family size and number of cars, and there is association. So it confirms statistically, it confirms the hypothesis that the car ownership depends upon the family size. So next thing, which is very obvious, this is a nice result that we also want to present our result in a graph form. So what you need to do for this graph is, so follow my steps. Go into the graph and check into the chart builder and say okay, and you going to see these different options of this bar chart here. So click onto this cluster bar, and then here you go ahead and select your variables. So I'm going to select the family size on an x-axis, okay, and the number of cars as a cluster. Okay, that's what I did, right? And now you see is by count. So we are not interested in count, we want to see a percentage. So on the element properties, you can check these properties here. So it's asking you what right now it's showing up as a count. So we don't want count, we want to see a percentage. So check onto the percentage, right? So right now the percentage is based on total 100, but we want to see a percentage based upon the each categories, which is like small family, large family. So we're going to set the parameters here, and we right now it's a grand total, which is out of 100, but we don't want this. We want this total for the each x-axis categories. Okay, so don't worry about other two, just what we want. Okay, and you say continue and say okay, and what we have is a beautiful chart. You can see that it shows up here, right? And of course percentage is not showing up, you can always click on here and ask for show the numbers, and here the numbers are. Of course you can always adjust how you want to see your numbers, for example. So this way number shows up, and this is the same percentage we were talking about earlier. So you can see that, and of course you can always change. If you don't like your 2 decimal places, you can always change your values. Right now it's 2 decimal places. You know what, I don't want 2 decimal places, I just want 1 decimal place. So you can always change those numbers. Okay, you can always make it bold, etc. So there's a bunch of properties you can check. So what you're really seeing in this chart here is this very interesting. Is this you're seeing is of course charts shows up here, by the way. Okay, and it's really showing us that the same thing basically what we saw earlier in the cross tab. Okay, exactly, we're seeing the same thing what we saw earlier in the cross tab here. Saying that is a smaller family have 90% of car ownership, 0, and you can see that between 0 and 1 cars 90%, and whereas in the larger families 5 or more have 77% car ownership. So this is how you do your chi-square test, and this is how you run your cluster bar percentage by cluster bar chart. Okay, so yeah, so give a try to your own project and have fun analyzing your survey data using SPSS.